The next concept that we are going to look at is implicants, prime implicants, and essential prime implicants. So first let's talk about implicants. Implicants are nothing but either the min terms or the max terms in your K-map or in the equation. Prime implicants, or it's known as PIs, they are basically the all possible largest group of ones. If you're taking min terms, then prime implicants are nothing but all possible largest group of ones. And then you have essential prime implicants, subgroups that can cover at least one min term, which cannot be covered by any other implicant. Your essential prime implicants, they are always included in your final equation. Let us try to understand these terms more closely using examples. Here I'm going to take a K-map with three variables. This is the K-map and these are the min terms. So let us first try to find out the implicants. Implicants are nothing but the min terms in the K-map. So your implicants are 4 in number because you have 4 ones. Now the next step is to find the prime implicants, which is basically nothing but all possible largest group of ones. So this is the first group, this is the second group of ones, and this is the third group of ones. Remember, it's all possible largest group of ones. Let me name this as 1, let me name this as 2, and let me name this as 3. So prime implicants are 1, 2, 3. The next step is to find the essential prime implicants. Now essential prime implicants are subgroups that cover at least one min term, which cannot be covered by any other implicant. So let us take a close look at this prime implicant here. In this one, it can be covered by only this one here. No other prime implicant can cover this. So it's an essential prime implicant. Therefore, 1 is the essential prime implicant. Now let's go for this one here. This one can either be covered by this one or it can be covered by this one. Basically, it can be covered by this prime implicant or the lower prime implicant. Therefore, it is not an essential prime implicant. Same case with this one. It can be covered by either this prime implicant or this prime implicant. Therefore, it's not an essential prime implicant. Now, when you consider this one here, it can only be covered by this prime implicant and it cannot be combined with any other thing. So 1 and 3 are your essential prime implicants. Let's take one more example. Here you're given that f is summation min terms 1, 5, 6, 7, 11, 12, 13, 15, and you're asked to find the number of implicants, the list of prime implicants, and the list of essential prime implicants. The first step is draw the K-map, plug in the min terms. Okay, now the number of implicants are, just count how many number of ones you have in the K-map. So that's 1, 2, 3, 4, 5, 6, 7, 8. So the total number of implicants are 8. Let's try to find out the prime implicants. Prime implicants are all possible largest group of ones. So the first largest group is this one. Then you have all possible ones here. So these are the prime implicants. I'm going to name this one as 1, 2, 3, 4, and the big one is 5. Therefore, the prime implicants are 1, 2, 3, 4, and 5. Now let's find the essential prime implicants. In this case, let's go for the subgroup 1. Now this one can only be covered by this minterm and not by any other. Therefore, it is an essential prime implicant. Next, this one can only be covered by this prime implicant. Therefore, it is an essential prime implicant. Similarly, this one can only be covered by this prime implicant. Therefore, it is an essential prime implicant. And finally, this one can only be covered by this group. Therefore, it is an essential prime implicant. As you can see, number 5 is not an essential prime implicant because they can be covered by this big one here or by individual ones here. Therefore, it is not an essential prime implicant. And if you look at your final equation, it's just going to be these four. So this is the concept of prime implicants and essential prime implicants.